Welcome to my video on construction of a sundial. What I'm going to cover in this video is I use the British Sundial Society's website to design the sundial. It's got some neat pictures in it and it prints out the templates that you need. And so I want to go over how I constructed it and take a first time observation, but I'm going to put off the discussion and analysis of the correction factors and error analysis in a coming video. Just didn't want this video to get too long. I'm focusing just on construction here. This is the British Sundial Society's page on how to make a sundial, and this is what I use to make mine. And so it takes into account the latitude and longitude where you're at. So I'm going to put in my latitude, and I'm at 38.2 degrees north, and now I want to adjust for longitude. So I'm going to be at 94.3 degrees west, and then I'm going to enter my time zone. I'm in the Central Standard Time Zone. There it is. Okay, now I've got my information entered into this calculator. Now I want to calculate. Okay, so this is going to be my outline, and this is for the actual sundial face, and this is for the gnomon. So what I'm going to do next is print these off. I'll put a link to this page because I had a little hard time finding it myself. So here it is, and then I printed that off, and then I started building my sundial from that. And then here's if you hit the print button. I tried a couple other pages from not the British Society and commercial pages, and they did not work that great. To be honest with you, there were so many pop-up ads that I couldn't even get the stupid thing to work. So I went to the British one. This one seems to work pretty good. Printed this off, and this is what I use. So I'll show you my design, how I actually built the thing in the next part of this video. From the British website, I got these templates, and the one on the left is this is the design of the dial face of the sundial, and this is the design of the gnomon. And you can see I've entered the 38.2 degrees, and that gives me the correct angle for the gnomon. And then you can see here that this placement of the gnomon, that line right there, is not exactly true north or the north of this. That's got into account the longitudinal correction, and I'll go over that, the details of that in a future video, but it's got some things built in. That's what makes this nice. So here's the gnomon diagram. I had to transfer that to a piece of, it's kind of a real thin piece of plywood. It's really not plywood. I'm not sure exactly what it is, but it's about a 1/4 inch thick. It's 1 notch above balsa wood, basically. I just bought it at my local Lowe's hardware store. So what I did was I put that piece of paper down, then I got a nail, and then I punched some holes at 3 or 4 different places here so I could draw the line and get that transferred properly. So then I got my square out, and I cut the angle. So there's my gnomon that I'm getting ready to cut out. What I did next was I glued the paper dial down to that piece of kind of heavy plywood. Well, it's not really plywood, it's whatever it is, a thin piece of wood. And then I put some nails, this nail and this nail, in where the gnomon is going to go, and that was to make a hole. But I'm going to pull those nails out in just a second and reverse their direction so I can put the gnomon on that line. So that's the kind of brown line is the gnomon line there. Okay, so what I did was I took those nails out and reversed them so they were sticking out. Then I put the gnomon on those nails to hold it in place. Then I put some heavy glue, just Gorilla Glue, wood glue on there to keep everything tied together. Now, once I had the gnomon on the board, I had to check the squareness. So I used actually my compass here. It had a square angle, so I just verified that the gnomon was vertical. If it's at an angle, it's going to cause a difference in your readings. Okay, so here it's all attached now, and you can see I've got the gnomon pointing north. And so I put all of this on a heavier piece of plywood because this thin piece of wood that I put everything on was not very sturdy. It had some warpage in it. So I screwed it all into a heavier piece of plywood to give me a nice flat surface so I wouldn't have any errors, and makes it more resilient and sturdy when I put it outside. So there you can see the completed sundial. And I'm getting ready for my first observation. I'm on the garage floor with the sun coming in, and I checked to make sure everything was nice and level. If it's not level, you're not going to get a correct reading. And then I also put my compass out there, and I've got the compass aligned with this little line right here, which helps me. So I'm pointing due north. The gnomon should point north. And so I took my first reading. You can see it there. The sun is pretty low in the sky. It was earlier in the morning, 8:30 in the morning, and the angle was very long. You can see the shadow of the sun is very long. And so that gives you, I measured that at about 7:55 is what the angle here was, or the time from the sundial. And so my first observation was the clock time was 8:32. The sundial read approximately 7:55. So now what I've got to do, and I took a series of observations up until about 2:30 in the afternoon. And so I want to go over those, and I'm going to go through and show you how to do the equation of time, what that means, that correction. There's three corrections I have to make here. Daylight savings time and the difference between the magnetic and true north. Now, there's one correction I don't have to make on this, and that's got to do with the longitude, the distance from the meridian of the time zone that I'm in. There's a correction for that. So they took that into account, so that's one thing nice about this. That's a topic of a future video. Working on that next. Well, thank you for watching. Hope you learned a little bit about making a sundial. It was kind of a fun project. I learned a lot about it, and hopefully you will too. Thank you.